Okay, this week on the show, we're going to be showing you how to do a fully encrypted installation of both FreeBSD and OpenBSD. So how cool is that? We've also got an interview with Damien Miller, one of the lead developers at OpenSSH, and he's going to tell us about all kinds of cool crypto changes in the project and just tickle our ears with all kinds of weird acronyms relating to the crypto world. So if you're into data security, today is the show for you. The latest news and, of course, all your burning questions will be answered right here on BSD Now, the place to be. SD. BSD Now, episode 16, Cryptocrystalline, recorded December 18th, 2013. Hi, I'm your host, Chris Moore.
And I'm Alan Jude.
And we're glad to have you guys with us today. We got a really cool show, right, as we're getting ready to go into the holiday season next week. But first, let's get to the headlines, see what's kicking this week in the BSD community, which, believe it or not, there is actually a lot happening right in the middle of New Year's and Christmas. So what's the first thing we got going on, Alan?
So the first one is a series of posts over here on a blog about securing your communications using OpenBSD and OpenVPN.
Okay.
So it's a multi-part series that'll cover everything you need to know about setting up VPNs between a bunch of machines.
Mm-hmm.
So it covers installing OpenBSD and setting up full disk encryption, which is...
So I guess this is in parts also.
Yeah,
right?
yeah. So this is in like 5 parts.
Okay.
So the part one is installing OpenBSD and setting up full disk encryption, which is actually part of what our tutorial for today is about, except for we'll be doing OpenBSD and FreeBSD 2 different ways. And then part two of their tutorial is the initial setup of OpenVPN, setting up certificates and keys and that. Part 3 and 4 will be the client and server configuration and getting that set up. And then part 5 will be anything that's left over at the end.
Sure. The last little bits.
Yeah, and corrections. But by the time you're on part 3 or 4 of the tutorial, somebody has submitted a correction to part 1.
Sure. Yeah.
As we've seen many times on this show.
Yeah. You almost have to come back a week later and look at the corrected tutorial and be like, oh, okay, so here's an easier way to do what we did in the show.
I did these two things in the wrong order, and it made a difference.
Yeah. But that's cool. Yeah. That's just how Unix is. I mean, there's always a dozen different ways to skin a cat. Everyone has a preference. Like, somebody's like, well, you can do that in sed, but what about I'll do it in awk? Well, I'm going to do it in some.
Yeah, exactly.
That's been going on forever. That's never going to change.
Yep. But if you're interested at all in setting up a VPN and securing your communications, this looks like a really interesting series.
Yeah, that definitely looks cool. Well, definitely check that out. We'll have the link for you guys in the show notes afterwards, of course. Yep. So next up, we have some new info from the FreeBSD Foundation. They've released their semi-annual newsletter, which just got published for December. So I guess in this newsletter, we got some information from the president, a letter from him.
Yep, it always starts off with a letter from Justin. So it's got a letter from the president, update on the fundraising campaign, which is currently in full swing. We're at about 54% of the goal, with about 1,339 donors. Apparently, I missed by 2. We could have caught it at 1,337. But we obviously want to get that number up some more.
Sure.
The total amount, it's nice to have that be nice and high, but the number of donors makes a bigger difference.
That's just as important, I think, like you said, if not more.
Yeah. So in order to pass the IRS's test for, I think it's the public service, to keep being a nonprofit and not be just a trade group of the companies that give the most money, they need donations. So if everybody could just donate $5, that would solve the problem.
Yep, definitely. So if you're out there and you haven't donated, and if you use FreeBSD in some way, this is a great way to give back and support the foundation, because they in turn are going to go out and support developers, support projects that need to happen and for the good of everyone in the community. That's
a lot of what this newsletter is about, is just recapping the things that they have done so far this year. Like the Newcon stuff is actually starting to land in head, and you can actually start using that now. The iSCSI target, a bunch of performance improvements for that are coming right now. UFI and Secure Boot, not quite done. Needed that last little push to finish that. It'd be great. You know, if you put your donation in and put, you know, UEFI in the notes there, that'll make sure that they know that all of those people are interested in getting that working sooner rather than later.
Yeah, definitely. And this is it's a cool way to do it, like you said, because it's not like just putting up a petition somewhere and say, I'd like you to work on this. Right. You're actually putting a few bucks, you know, put your money where your mouth is, you know, I really want this feature. Here's a few bucks to help go towards that.
Because, you know, UEFI isn't anything that any particular developer's day job really required, because servers are not going to require that for booting for a while yet.
Sure.
But it's something a lot of people want. And so...
Yeah, and we're seeing it creep up in more and more appliances out there. So might as well get someone on it, get it supported sooner rather than later.
But one of the other main goals of the FreeBSD Foundation is getting corporations to understand how to interface with open source projects. A lot of times there's very... You know, they're confused about exactly how it's going to work and what's going to be required of them and so on.
Yeah, they don't know, like, oh, go hit the mailing list and find the developer who's interested in working on that wireless driver and then contact him. I mean, they expect a phone number or an address, one person to contact.
Or even sometimes, you know, they need to make a contract. There needs to be a legal entity, and that's what the foundation is for.
Yeah,
but
they can sign the NDAs.
The foundation also... to attract corporations to use FreeBSD, publishes a series of white papers, including the one that New York Internet did. We talked about this a month or two ago when it came out. But it's about how to do managed services and web hosting stuff with FreeBSD. And it shows using features that are specific to FreeBSD, like HAST for block level storage replication, or ones that are not specific to FreeBSD, but OpenBSD and FreeBSD, like CARP, to manage failover between different machines and stuff. So it's quite useful.
Oh, very cool. Well, of course, so this newsletter is actually really long. There's a lot of details, a lot of stories from the conferences in case you missed those and want to get a little recap.
Well, yes, because...
of course, the projects as well.
They sponsor people going to the conferences, and then in exchange for that, the person has to provide a report explaining what they did at the conference, what they gained from it, and, you know, justifying the money they spent. But a lot of the money the foundation gets goes to getting the developers to conferences, because, you know, these developers are donating their time to the project. It's not always possible for them to also be able to pay to fly to Malta to take part in the summit. But if they do manage to get there, the value that the project gets out of that can be really big. Like, you know, when we were at Malta, we saw the group of people over in a corner, and a couple hours later, there's a solution to a problem.
Yeah.
Or
the face-to-face track is just really, really important, and the conferences are invaluable for that. You know, ask any of the BSD projects. You really need that FaceTime with people versus long-winded email threads and even little pokes on IRC.
Yeah, because, you know, it takes longer to explain something via email. You know, tones and stuff can be misinterpreted in email, whereas when you're face-to-face, there's less chance of a misunderstanding, and, you know, it's the easiest way to resolve even a conflict is face-to-face. Because afterwards they can go out and get a beer, you know, and just chill. But also, it's
relax as normal people and not as identities on the mailing list.
And I introduced Peter Hessler to Peter Grehan, and, you know, a week later you can boot OpenBSD in Beehive. It's like, you know, that might not have happened if they both couldn't have made it to the conference.
Sure. So definitely go check out the newsletter. Take a look, and if you haven't donated yet, try and get that in by the end of the year, and that'll be helpful for them going into the new year.
So whatever you could spare, but even just $5, the count of people makes just as much difference as the amount of money.
So next up, we have an article about the use of NetBSD with Marvel Kirkwood processors. Ooh, interesting. So I guess it gives a brief history of NetBSD and then how to use it on an IP plug computer. So for those that don't know, I have a little description here. The IP plug is a multifunctional mini server that was developed by Promod engineers on the order of AK Systems. It's designed for solving a wide range of tasks in IP networks and can perform the functions of a computer or a server. It's powered from a 220-volt network and has low power consumption as well as small size, which can be compared to like the size of a little mobile phone charger or something. That's really cool.
So you got a picture of it here up on the stream. So it's got a European-style powered connector. So basically, it's about the size of the adapter you would have for a lot of random pieces of electronics. So
Sure.
it plugs directly into the plug, hangs out of there, and it's got 2 gigabit Ethernet ports, and it's a device that runs NetBSD, and you can make a router on it or whatever you need to do. So it's got 2 gigabit Ethernet ports, 2 USB ports, 802.11n wireless and Bluetooth, a gig of RAM, and a 1 gigahertz processor.
That's really cool. That reminds me of those little like Wi-Fi routers we got in Japan that are like the size of a box of matches.
Yeah, like half the size of a deck of cards.
Yeah, just fantastic.
But yeah,
They
so
boot up off a USB power.
yeah, so this one's just basically this little device you can plug straight into the wall, and it'll be your wireless router or whatever.
That's very cool. So I guess this is just a really cool little NetBSD ARM project, and on the link here we're going to have a lot of pictures
Now,
and
there
graphs,
was
details.
a different plug device based on I think the same processor that FreeBSD had support for. It was
you remember which one it was?
a Marvel plug computer, but it was one that actually had like a VGA port. I don't know. There's some stuff on the wiki about it. I'll have to see if I can find that.
Yeah, I have to go find that. That'd be interesting.
Yep.
Well, cool.
But yeah,
So
little ARM machine, and so I'm sure that OpenBSD and FreeBSD will be running on this in not too much longer as well.
yeah, definitely. Okay, so what's the next story we have for the week, Al?
The next one is from Adrian Chad, who most people know him as the wireless guru that does a lot of this wireless stack stuff for FreeBSD. But now his day job is at Netflix and doing network performance tuning. So he's been working.
Why would Netflix need that?
He's been working and managed to get up to 35 gigabits per second pushed out of a single machine using, I think it's 2-port 10 gig Ethernet adapters. And he's not done yet. So he's seeing what else he can do. Yeah. So he's kind of looking at doing zero copy network IO using FreeBSD current. Version 11 there. So he looked at a couple different ways, and one of the things he's looking at doing is FreeBSD has send file, which basically says instead of the daemon reading the file off the disk and then writing it to the socket and the back and forth that's involved there, you can just have the kernel say, hey, this chunk of the file needs to be sent to the socket. Take care of it. So now he's looking at a way to do that with POSIX shared memory segments. So you can do stuff that's already in memory instead of having to have it be a file on the disk. And the pros and cons with that, and seeing what else you can do. Also having asynchronous completion notification so that you can find out when it's done. So before, the option where you send it and when it's done, whatever. Or if you needed to know when it was done, so you could then say write that file, like overwrite that space of memory, you had to make your app sleep and wait until it was done. Now it'll be an asynchronous. You'll just get a note back saying, hey, this is done now. You're free to clean up or whatever.
Yep. Oh, that's very cool. That's exciting to see. So I assume it looks like experimental stuff at this point. Nothing's committed to it yet.
I think a little bit of stuff in it, but most of it, he's got a GitHub branch where he actually has a library for this called app. What's it called? libiapp, which is designed for really high performance networking stuff.
Yeah, he says he has a working prototype that's scaling quite well under load, and he's looking to commit it to FreeBSD heads soon.
Yep.
Oh, nice.
Exactly.
Okay. So coming soon. That's fantastic. Well, Adrian, keep up the good work. That's cool. Very, very cool. So, of course, check out the link. You can read his full write-up on how this works, some of the gory details if you're interested in what's happening in the kernel and stuff.
Yep.
This is pretty slick. Well, awesome. Well, that's going to be the end of the weekly news roundup. But next up, we want to just go ahead and mention our sponsor for the show. Yeah. So this week's show is brought to you in part by our sponsor, IX Systems. So if you're looking for a quality Intel server and support for BSD operating systems, well, look no further than IX Systems. Their professional sales and support team will ensure that you end up getting exactly what you need with the quality you expect. Each server goes through a battle-tested QA process and can be pre-configured before it ships to you. So get a pre-purchase consultation and find the solution to your challenge today.
Yeah, and so I just noticed on their Twitter feed they have a little bit of geek porn going on here. A machine they just built a special order for the FreeBSD Foundation, which will be going to the project, is an 80-core server with 1 terabyte of memory.
That is a pretty picture.
Yeah, so it's a 4-way, so it has 4 processors. Each one is 10 cores, and then with hyperthreading, that adds up to 80 logical cores. And as they said, a terabyte of RAM shoved in it.
That is incredible.
Yeah, so I'm not sure, but I'm guessing this is going to have something to do with the Poudre class, right? Building packages and stuff.
Yeah, I would imagine they would be cranking many packages.
Or just building the whole world a lot for, noticing when things break. But either way, that's a very nice machine that I'm sure everybody wishes they had one of these.
Yeah, all of a sudden, my 16 core seems so underpowered with only 196 gigs of memory.
Yeah.
It's just so weak.
Yeah.
Well, that is awesome. Definitely take a look. We have the link in the show notes if you want to see the picture of what that looks like.
Yep.
But next up, we'll be playing an interview with Damien Miller, who will be talking to us about all kinds of cool cryptology in OpenBSD and OpenSSH. So stick around for the interview up next. Okay, we're joined this week with Damien Miller, OpenSSH developer, and he's here to discuss some of the recent crypto changes in OpenBSD. So welcome, Damien.
Hi.
Hey, good to have you with us. So the first question we ask pretty much everyone. So first, give us a little bit of your history about yourself, how you got involved with BSD, and what kind of led you to this point.
So I actually got involved with BSD via OpenSSH back in the late 1990s. I was working for a company here in Melbourne, Australia, that managed Linux firewalls, and we needed a way to manage them, so remotely. And we were using the old open source SSH1 versions, and that worked pretty well. That was what everyone was using at the time. But the authors of that program, the authors of that software, decided to start a company and progressively made the licensing more and more restrictive. So we were sort of marooned at a version that was unmaintained and we couldn't look after.
Sure.
And around that time, the OpenSSH project started, and I quickly saw that it was going to be a good fit for our needs, and ported it to Linux.
Okay.
So I think within a week or two of it OpenSSH being announced by OpenBSD, I'd started the porting effort, and I continued doing that for a while, and then graduated to making changes to OpenSSH itself after 6 months or a year or something like that. And then I started using OpenBSD because I needed an OpenBSD system around to properly test my changes, and found that I liked it and stuck with it since.
Makes sense.
So what got you interested in cryptography in the first place?
Well, I suppose I've been working in information security and with Unix systems for a few years by that stage. My first sort of semi-real job was setting up a web hosting company in Singapore in the mid-1990s, before that was one of the first ones around, really. And I sort of quickly realised that cryptography was the only thing that would give people any reasonable expectation of privacy on a public internet, where the opportunity existed for various people to sniff traffic along the way. And certainly recent events have vindicated that view.
Yeah, you were justified in that position just a bit. So
Oh, sorry, go on.
Let's say, go ahead and describe the process, though, how you became an OpenBSD developer. What was that like, getting plugged into the community?
So it was interesting. I think, well, my contributions to OpenBSD certainly began with OpenSSH, and OpenSSH only for a little while, and they sort of spread out from there. I've touched a few other things in the tree, and written some small kernel drivers, and then touched various other bits. I maintained the import of OpenSSL, and I still do. But the heavy lifting is definitely not done by me. I sort of help out with the crypto bits and various other things. Back when I was doing more network related stuff, I'd help out with a few of the network daemons as well. But these days my job's pretty much purely information security, so I pretty much stick to that.
So I guess you already kind of answered this, but so it was initially you just worked on OpenSSH, and then later on you got into doing more OpenBSD stuff?
That's right. Yeah. So yeah, I think for the first couple of years I only really touched OpenSSH, but I'd work on other things as they sort of interested me, or as I found a need for them in my employment or my personal use of things, which is really how OpenBSD's developed, right? It's a bunch of people solving their problems
for the good of everyone.
As well as other people. Yeah, yeah.
Yep. So right now, what places do you personally use BSD, or which ciphers are you using as well?
At the moment, I just use OpenBSD personally. So I have a few systems here that I use as a firewall for testing, for development. And for the ciphers that I'm using, it's really OpenSSH is the main thing that I sort of consciously select ciphers for. I usually just accept the defaults of what we ship. We try to keep the defaults as being our recommendations for the world at large. So our top ranked cipher, I think, at the moment is AES 128 encounter mode, which is it's a very, very well reviewed and well understood cipher. It was arrived at through an exhaustive process. So we have good confidence in that. And the same's true of the other algorithms. I mean, we change them from time to time, and we're actually going through a process of looking at some of them now, which I'm sure we'll talk about in a few minutes. But generally, the exception to that is when I've got a special need or when I'm testing something. So often when we commit support for a new cipher, I'll make that the default on my systems for a while, just so I can shake out any working problems that we have. And if I've got special needs, like for example, high performance on the local area network, I might choose a cipher that's faster and less secure, and a little bit less secure, because I have some confidence in the local network.
Right. Well, I guess there's a patch now for threaded AES on your LAN.
Yes, so people wrote a patch for a AES counter version, counter mode, that offloads the key stream generator to a helper thread, and that does improve parallelism. But in OpenSSH, we don't want to introduce threads. Right. I think it just adds a lot of complexity to what we try to keep a simple daemon that we can fit in. I mean, it's complicated enough, right? But if we add concurrency to the inherent complexity of the code, then we're just going to go crazy and not be able to reason about it as clearly as we can at the moment. Right. I think ultimately something like that probably belongs in OpenSSL itself. And it should be fairly easy to implement that as an OpenSSL engine. It's also sort of, it's kind of different to the way that things are moving, where CPUs are getting good hardware acceleration for AES primitives, and we don't really need to spend quite so much time speeding them up in software.
Sure. Right, and if you're trying to do 10 gigabits over your local LAN, there's always the none cipher, right?
Well, we don't actually support that, and we never have. Various people patch that in, and I think it's a moderately bad idea. Enough that we've always resisted including it in the ones that we offer. I think it's like a 3-line patch or something like that if people want to hack it in there. But I just think it if people want to go without encryption, they can use Telnet.
Well, you want SSH for the key login and all that stuff, and then you can drop it, the encryption, once you're just transferring a file over your LAN or whatever. Yeah,
well, I mean, so the none cipher removes the encryption overhead, but it doesn't remove the overhead of the message authentication code. and that turns out, if you're using the cipher like a really fast cipher like RC4 or the new Cha-Cha one, then it turns out in most cases the HMAC or the MAC overhead is greater than the symmetric, or like the fastest symmetric ciphers. So you're not actually, you're gaining a few percent speed up at the cost of blowing your security.
Right.
And it's also like a very sharp tool to leave around. We try to we take a slightly patriarchal view of things, where we try to keep the playpen safe for everyone, right? If people misconfigure their SSH configs and accidentally apply the non-cipher to everywhere, then it becomes they've blown their security.
I suppose the version of the patch I use refuses you to give you a shell if you're using the non-cipher. Yeah,
really?
So it'll only do it for like SCP and SFTP. It refuses to give you a shell if you're using the non-cipher. But there could be a bug there somewhere where you could end up with it when you're not supposed to. But
right, you could file some more corners off it, I suppose, if you only allowed key-based logins with it, and but that also presumes that you're not transferring anything sensitive enough to care about.
In this case, we use it for uploading like our package sets, which are public. They're just going out to the net anyway. So.
Right. Yeah. I think no one's ever done any benchmarking that would make me consider, the non-cipher really essential. Like the bottlenecks in SSH are not so much to do with the crypto. Not so much to do with the symmetric crypto as with the MAC. Some of the internal buffering, TCP, bandwidth delay products.
Right. Well, that's a separate patch, right? The HPN.
Right. Yeah. So some people wrote a patch to address some of the TCP and buffering related bottlenecks, and we weren't really happy with at least the initial versions of the patch, because they made some changes in the buffer API which caused almost unbounded buffering. So the SSH one peer could grow arbitrarily large in its memory consumption. And a few years ago we adjusted the buffer sizes so that and I think we adjusted it for something like a target of 100 megabit connection from like Europe to the East Coast USA, or Europe to the West Coast USA, and that was enough for the vast majority of users.
Sure.
There's some cases where that's insufficient. So if you've got gigabit connectivity, like you're on
between
the internet,
Germany and Toronto, gigabit. So that's why I use the HPN stuff.
Yeah, so I think it could well be time that we revisit that, but I didn't like the approach of the HPN stuff. They made some decisions, particularly to do with buffering, which I thought were a bit dangerous.
There are some options to control the maximum size of the buffer, and it's also limited by the socket buffer on the host OS, but it's not as...
Yeah, so I think the thing that we need to do is look at the TCP buffer sizes and use that as a guide for how to size the socket buffers, how to size SSH's buffers. I think is is probably the right way to do it, because then you can set your TCP stack to tune up to the limits that you like, and have SSH follow. It's a subtle area though, because you don't want to hose your system by having massive TCP buffer sizes followed by massive SSH buffer sizes. We want SSH to be the thing that lets you log into your system even when everything else on the system is completely broken. And if SSH becomes the thing that exhausts all your kernel memory and causes your system to grow, then we've done worse than fail.
Right. I guess you have to kind of somehow find the way to tune for the tiny embedded machine that's running OpenSSH to let you log into it, and the big server with multiple gigabit connections and 128 gigs of RAM that just wants to go fast. Yeah,
that's right. And I think looking at the TCP buffer sizes is probably a good heuristic to make that transparent to the user. If they're setting their TCP buffer sizes or the kernel's doing it for them appropriately, then that means SSH will follow. I don't know. We might require another knob, but we try not to add those.
Right. Sure. Well, I guess, can you tell us a little about some of the recent crypto changes that have been made in OpenBSD? I guess RC4 is being replaced. We got a new Cha-Cha 20, Poly 1305, ED 25519. I mean, and the list goes on. So what's going on over there?
Yeah, so I suppose there's been a lot of renewed interest in what cryptography is considered safe, and some of the Snowden revelations have contributed to that. There's rumours that RC4 might be even more broken than we thought it was. There's actual documents from the NSA that say they have, quote unquote, some capability against SSH. We don't know what that is, but and we really can't without more information. So it has sort of prompted us to look at things a little bit more closely and replace things which we perhaps should have a little while ago, like the use of RC4. The replacement of RC4 was OpenBSD's ARC4 random, strong random number generator function, which has used RC4 since the late 1990s or before even. And that's recently been replaced with Daniel Bernstein's Cha-Cha 20 cipher. And that's a pretty well-reviewed cipher. It came from Salsa 20, which was a cipher that went through the European Stream cipher contest, or the eStream contest, and won, or was one of the winners at least. So it's a tweak to that, and it's considered to be pretty well-reviewed and a good cipher. It's also used as a basis of a number of other constructions. So using as a stream cipher, it can be used for encryption, or it can be used to generate a key stream, which is strongly random. So we basically moved out RC4 and replaced it with Cha-Cha 20. So we're in a slightly funny position now of having an ARC4 random function that doesn't actually use the ARC4 cipher now, but people use the function for its properties, not because of what's under the hood.
Sure.
So that's one place where we've made some changes, and OpenSSH is the other place where we've had a fair bit of activity lately. We've added support for a new elliptic curve Diffie-Hellman key exchange function, which is the curve 25519. It's called curve 25519 at libssh.org. So this was contributed by one of the libssh developers. Came up with and contributed. It's a Diffie-Hellman key exchange agreement in curve 25519, which is an elliptic curve developed again by Daniel Bernstein, which has some very nice properties which make it secure and fast to do computations in. So it's a good complement to the NIST curves, with which some people are considering a little bit suspect, because they've got some constants in there which we don't know how they are agreed with, how they were developed. I think that the concerns about the NIST curves are probably a little bit overblown, but people want alternatives, and this has some better properties as well. So we can. It has no sort of constants that might potentially have been tweaked by the NSA. It's literally the smallest curve. It's the smallest the curve's defined by the smallest numbers of the particular size that meets the criteria that Bernstein laid out, which is a nice way to design things. So that's a new key agreement function, and I believe it's a default. It's well tested, and there's some good public domain implementations of it, one of which we imported for OpenSSH. We've added a couple of other things. There's a new symmetric cipher, a new symmetric authenticated encryption cipher, which is Cha-Cha 20 Poly 1305. And this is a combination of two primitives, Cha-Cha 20, which I've described earlier as a stream cipher, and Poly1305 is a one-time MAC or message authentication code, and we basically follow the construction used in libNACL, which is a cryptography library, and also in Adam Langley's similar proposal for TLS. So you basically run char-char-20 to generate a key for the MAC for each packet, and then you encrypt the packet, and you calculate the MAC and append it. So it's kind of like running it's an authenticated encryption. It's authenticated encryption. Well, I should back up and say what authenticated encryption is. Authenticated encryption is basically a cipher mode which offers both confidentiality and integrity. So you can't see what the data is, and you can't tamper with the data, and it offers that in a single primitive. So char-char-20 and Poly1305 are technically separate algorithms, but our combined use of them forms an authenticated encryption.
Complementary in many ways.
They are. So Poly1305's got some requirements on it that are very different to the message authentication codes that we're used to, like HMACs. So you can only it requires a new key for every packet is the big one, and if you get that wrong, then it's trivially broken. So you really need to use it in a special way, and one that doesn't fit particularly well into a lot of the protocols that were designed in the 1990s, like SSH and TLS. So it doesn't work. It just doesn't fit into the way they've intended to negotiate keys and MACs. But the combined algorithm works very nicely. And we went a little bit further with char-char-20 and Poly1305 because most authenticated encryption ciphers in other protocols will, and in SSH, will send the packet lengths in clear text, just because you need to know how long the packet is before you can pull it off the wire and calculate the MAC and everything. I've never been really comfortable with that. I think it just makes traffic analysis a little bit too easy. So we keep a second instance of char-char-20 around just to encrypt the packet lengths.
Oh, cool.
That allows us to maintain the privacy of packet lengths while not offering any sort of decryption oracle to the main packet payload or the MAC. There's a little bit more overhead, but char-char-20 is very key agile. I think it's like a 16 or 32 words of key is the state, and it's very fast. It's faster than RC4. So that's very little overhead, and provides a little bit of benefit. I think it'll, I say that we want to protect the key lengths, but we trivially leak them in a lot of cases just by packet timings and replies and things like that. Hopefully, we'll be able to implement some countermeasures to that in the future as well.
So some of these ciphers have kind of hard to remember names, especially when you add a bunch of random numbers. Who do we blame for all of that? Is that mostly Bernstein when he came up with them, or?
I guess so. Yeah, they're the names. Don't blame us.
Because I look at Poly 1305 and go, okay, were there 1,304 of them previously, and this is the one that we like now?
Yeah, you're asking mathematicians to come up with like funky names for stuff. I mean, sometimes it works, sometimes it doesn't.
4 digits is okay, but when you get to 25519, it's like, how am I going to remember that?
Yeah. Well, I mean, hopefully, I think there's for some of these things, I think they're likely to be the default in the future. So hopefully you won't have to remember them. And the last thing we added was ED25519, which is a signature scheme, also by Daniel Bernstein, which Marcus has just implemented a public key system around, public key authentication for users and hosts. So it's a new public key type that you can use. And ED25519 has a couple of nice properties. It's fast. It's comparable speed to RSA. It it doesn't require runtime injections of randomness like DSA does, or ECDSA.
Sure.
And DSA and ECDSA have this terrible flaw where if your randomness is predictable, then your private key is exposed. And this most famously bit Sony a couple of years ago when their root keys for the PlayStation were exposed because they had a crappy random number generator, or maybe even a completely absent one. And they did more than one key with the same randomness, with the same nonce, and that enabled some people to do some fairly basic computations to extract the original key. Now ED 25519, see, I'm fun
exactly.
It avoids that because it doesn't need it. The signatures are completely deterministic. So like RSA, RSA has that property as well. So RSA and ED 25519 are good like that. RSA requires these big keys though, and ED 25519 is like 32 bytes on the wire or something, something small. Well, and it also had a nice public domain reference implementation that we could import and use. So it's attractive from that sense. And this actually brings, with the addition of these three new algorithms, a new key exchange algorithm, a new key algorithm, and a new symmetric cipher /MAC. It brings us very close to being able to build a very slim version of OpenSSH that doesn't link against OpenSSL at all. Now, it wouldn't be one that's standard compliant because we wouldn't support some of the things that are, like we wouldn't support DSA and 3DES and things which are specifically required by the RFCs. But it would be very small and standalone. So that's kind of interesting. We'll probably pursue that. Hopefully for the next release.
Well, you just mentioned these a couple times, but what had prompted the change from RSA to ECDSA? By default, are there any concern?
We haven't changed.
We haven't.
Oh, so actually, I think we might prefer ECDSA keys. We've assumed for a while that hosts have decent sources of randomness. And if you assume that ECDSA's got some nice properties as well, like it's fast to calculate signatures, it's well understood to have a good security level, and internally it uses modern hashes. So the SSH RSA and the SSH DSA both use SHA-1 internally, which is getting fairly old. It's not broken like MD5, but that we're at the point where we should be starting to switch away from it. Microsoft's deprecating it in 2016. I think the NIST or FIPS standards recommend turning it off by the end of this year. So we don't, and nobody's come up with replacement key algorithms for SSH, which use the the newer hashes. So there's no SHA-256 or 512 version of RSA and DS application specified for the SSH protocol. People want to be FIPS compliant and use SSH, so ECDSA is the best option for them at the moment.
But do you expect to change that to the ED 25519 in the future?
I could see us doing that. I could see us making that the default in the future. But it's pretty new, and it's a big blob of code that's just landed, so we're not doing that yet.
All right. So were there any other particular reasons to move away from RSA other than, like you said, the older hashes? RSA is still supported, and it's still widely used. In fact, when we added code for the new public key types, we wanted to make sure that people didn't start getting warned about new keys. The server host keys changed just because we added new key types. So we basically preference the key type that people have already learned.
So if you've learned an RSA key for the host that you connect to, then you'll continue to use that RSA key, until you decide to learn a new one.
Sure.
We're looking at ways of, if you've learned it, when you connect to a host, it'll send you all its public keys, so you can learn, potentially better algorithms without having to, type yes or,
right. Get the big scary warning.
Yeah. No.
The big scary warning is also, if you see the big scary warning and you're not checking it out fully, then that's a chance for someone to slip in and own you, right?
Right.
So we want to show, we only want to show the big scary warning in cases where there's actually something's actually changed.
Sure.
So I guess
how about the
you did the change recently as well to support DNS or SSHFP if you have DNSSEC?
So that's been there for a while. I've only ever used it in a test environment. I've not. DNSSEC seems finally to be slowly creeping out into the world at large, and slowly starting to make its way into system resolvers. So I think we'll see more of that in the future. But that was written by Jacob, who does a lot of the DNS stuff in OpenBSD, and I don't know a huge amount about it myself. I think it trusts the system resolver to do all the DNS stuff, right. Sec stuff, sure. And assumes it's doing a good job. But it seems like that seems to be the best argument. One of the good arguments for DNSSEC is that you can distribute key material via the DNS.
Well, how about with the new SHA-20 and Poly 1305? Do you think this is secure enough to recommend it to everyone, even though it hasn't, say, gotten as much review as maybe AES or SHA-256?
Well, it's not our first preference cipher at the moment. At the moment, we're sort of really, I'd see it as a much better replacement for RC or the ARC4 modes at the moment. Again, in the future, maybe, I don't know. I mean, it's a difficult thing to judge, really. I'm not a cryptographer. I suppose I'd call myself a cryptographic engineer. I leave it up to the mathematicians to I base my judgments around what the real cryptographers say, and I think AES is still considered a very, very well reviewed and safe algorithm. I don't think there's been any substantial doubts about that. So I think I will add one thing though. The SHA-20 Poly 1305 is faster, not just because of the cipher itself, but also because it's the Poly 1305 MAC is faster than HMAC in a lot of cases.
Sure.
So you're getting speed ups from two places rather than one.
Cool. So is there anything else people should be aware of? Any new changes going on? What's next?
I've been so sort of wrapped up in getting the cipher stuff done that I've completely forgotten all the other changes that we've made. Fortunately, we try to polish off a bunch of bugs every release, and try to implement at least a few new features that people have asked for via the mailing list in our bug tracking system and in person. So there's always, we tend to do a sort of like a TikTok thing where, one release we aim for more features and the next release we just sort of try to do more bug fixes. Sure. But it's not a pure thing. There's always some of each, except for security releases, which are a special case of bug fixes.
When do you expect us mere mortals to start getting our hands on some of these new things?
So we aim for releases every 3 months. We're not always successful at that, and sometimes it's as long as every 6 months. Sure. I'd like to get one out this year, but I don't think it's going to be feasible. So in all likelihood, I suppose it's going to be mid-January. We might start a call for testing late this year. But I think, mid to late January is probably when we'll make our next release.
Oh, cool. Okay, anything else you want to mention before we close here?
No, it's been a pleasure.
Oh, well, thank you so much for being with us, Damien. This was enlightening and making my head spin a little bit, but I'm going to have to go read some more. Next up, we're going to be taking a look at our tutorial for this week. So the topic, full disk encryption in both FreeBSD and OpenBSD. So as you know, protecting your data is very, very important. I mean, you can have the tightest network security in the world, but if someone actually gets into your location and has physical access to the machine, I mean, that's pretty much worthless. So in the tutorial today, we're going to be showing you how to set up an encrypted installation, say of FreeBSD or OpenBSD step by step, which hopefully will thwart anybody who walks by your system or gets a hold of your laptop, etc.
Well, yeah, so a stolen laptop, I guess, is the biggest one, right?
Yeah, that's where I use my encryptions because I'm always worried about, losing it in an airport or a hotel or something. But even so, I got servers at my house. Maybe I'd want to encrypt those as well.
Mm-hmm.
But what are you going to go ahead and show us here first?
First I'm going to do FreeBSD the manual way, which is what you need for 9 or earlier. In 10, if you're going to use ZFS, the ZFS boot option in the installer that Devin Teskey and I wrote will do this part for you. But if you want to use UFS or you're using 9 and doing it automatically isn't an option, then you'll want to do this way.
Okay.
So you basically start a normal installation like you would anyway.
Mm-hmm.
So I'll name my machine and select the various distribution sets and so on that I want to use. I'm doing a network install, so I have to configure my network. Select the FTP mirror. And now here, normally, if you were doing an install, you would use the guided mode or whatever and create your partitions. Because we want to install to an encrypted partition, I'm going to use the shell mode and create the encrypted partition by hand, since the guided mode doesn't have support for that. And I'm not going to use the ZFS option because we're assuming you're using 9 or for some reason want to use UFS. So the first thing to do is to figure out what disks you have. So there's a sysctl here that lists, and we can see ADA0 is the disk in my machine. That's what you'll see for most machines that have SATA disks. If it's SCSI or SAS or something, it'll be DA0 or whatever, or USB is also. And there might be different numbers, and you can also do can control dev list. Will give you a little more detail about what each one is. But anyway, once we know that, we have to go and start building our machine. So I'm going to use the gpart command to create a new partition table. So I created let me just get rid of the old one first. So I'll create a new partition table. We'll use GPT because it's better. But you can also do an MBR if that's what you need to do. And then I'm going to create the partitions. With GPT, we'll create a small partition at the front of the disk. Type of FreeBSD boot, and this will basically hold the boot code. So it doesn't need to be very big. I do 0.5 MB mostly because I align all my permissions to the 1 MB barrier. So all that space at the beginning of the disk is empty anyway. So why not use it for the boot code?
Sure.
And I'll also add. So I'll create a UFS partition here, and I'll set a label of bootfs. So in FreeBSD, you're going to need a small partition that's not encrypted that you boot off of. And then once you have a kernel, you can then load your encrypted partition. Yep. So I'll make that, say, 1 GB, and then I'll align that to 1 MB. And if I do gpart show, you can see I have 2 partitions. And then now I'll just add a third partition. Again, FreeBSD-UFS. And I'll label this one encrypted. And by not specifying a size, it will use the rest of the disk, all the space there.
Just fill her up.
So now you see I have a 1 GB unencrypted partition and a 15 GB encrypted partition. Although it's not actually encrypted yet.
Yes.
But we'll get to that in just a second.
Planned.
Yes.
Planning to encrypt it.
So then we'll install the boot code. This command will be different if you're using GPT. Or sorry, MBR.
Or ZFS.
Yes. Yeah. If you're using ZFS, it'll also be different. But if you're using MBR, it'll be different as well. So anyway, that's now installed the boot code into that little partition we created at the front of the disk. So now we can go about actually setting up the encryption. If you look in the man page for this GELI, or as Chris likes to say, jelly command.
The jelly. Yep.
If you read the man page, you can see all the extra options you have about creating, selecting which encryption algorithms, or if you want authentication as well as encryption, which basically means instead of having 512 or 4096 byte sectors, you'll use slightly larger ones that'll include the hash of each sector as well, so that encrypting your disk ensures that no one else can read it. But when you add the authentication, it makes sure that you can tell if someone has changed it, which can be important in some cases. So anyway, we'll do jelly init, which will set up a new encryption thing, and then we'll do 4096 byte sectors, and we will pass it the partition we just created, ADA0 partition 3, which will be the encrypted partition we created.
Yep. The rest of
So
the disk.
now it'll prompt us for our passphrase. So we enter our super secret secure passphrase, which is used to encrypt the 256-bit key that'll be used for all of this. Now we can attach the device. So when we do GELI attach on ADA0 partition 3 and put in our super secret secure password again, a new device will be created called ADA0P3.ELI, which is
That's basically the raw, the unencrypted.
well, no, yes, it'll actually give us the interface that we can talk to, where we'll be able to access the files unencrypted so that we can read and write to them.
Yep.
That's good. So now we can format the two partitions we created. So we'll do new FS for our partition 2, which will be our boot sector, or boot partition. And then we'll do it again for partition 3.
Dash U, is that for the soft updates?
Yes, and I have to include the .eli, because you see when I try to write to the raw disk, it's like you can't do that. It's being used by the encryption provider. So now, the way this manual mode works in the FreeBSD installer is that you create your file systems however you want and mount them under /mnt, and it will do the install to there. So what we'll do now is mount dev ada0p3.eli to /mnt. So now our encrypted partition will be / in our target system. And then I'm going to create a directory called unenc, meaning unencrypted. That way we know if we're ever writing anything there, we'll be reminded that it's not encrypted. And we'll mount our not encrypted partition to there. And then we'll create, under that unencrypted partition, a /boot directory. And then we'll make a symbolic link to that unencrypted /boot in /mnt/boot. So now when we go to our /mnt system, we see that it's actually a symbolic link to the other partition, and that'll hold our unencrypted stuff.
That's your kernel and your bootloaders and stuff.
Yeah. So now if we go to, so now what we have to set up is our FS tab. Install etc, and you can put whatever you need to put in your FS tab. So we'll put, we'll have dev ada0p2 will be mounted to /unenc, right? Because our unencrypted partition. Yes. And then we'll have ada0p3.eli will be mounted to /. And the last thing we need to do is edit /mnt/boot/loader.conf. And in here, we need to tell it to load the encryption module. So this will load it in the kernel so that as we progress through the boot, we'll actually be able to mount that encrypted partition.
Mm-hmm.
And we'll say that we want to mount the root partition from 80p3.eli. So now when we type exit, it's going to go back to the installer and install our system into that /mnt directory. So now I'll quickly show you how to do it in OpenBSD.
Yay.
So I've booted the OpenBSD installer CD. So what we're going to do is choose to drop to the shell again, same kind of procedure. And then we'll use fdisk, and we will write a brand new MBR boot sector to our disk, which is WD0. And then we'll use disk label to label that disk. And so, again, if you follow the tutorial correctly, we'll create a partition B. Oops. Why is that not done what I wanted?
Uh-oh.
I think I have to reboot after you do that to make it realize that there aren't any partitions there still.
Oh, okay.
Slightly complicated because I did this tutorial earlier to make sure it worked. And that's actually breaking the tutorial because that's how that goes.
Uh-huh.
Luckily, OpenBSD boots really quickly.
True.
I think their version of their install CD that doesn't have the actual install files on it is like 7 megabytes.
Wow.
It's like, that's a small CD.
Mm-hmm. So in the example, are they doing MBR?
Yes. The OpenBSD one is doing MBR. I don't know if OpenBSD does GPT yet. I've never looked at that. So anyway, fdisk.
Yeah, when I see the fdisk command, it makes me wonder.
And then we'll do disk label. We'll add partition B. Okay. How do you do this again? There. Add partition B, and we'll make it 1 gig, and we'll make the type swap. And then we'll add a partition A, and we'll make it the rest of the disk, and we'll set the type to RAID, because we're doing fake software RAID so that we can encrypt it. So now we have our 2 partitions. Okay. So now then we can do BIOCTL and this magic. And this will encrypt our WD0A, which is the first partition on our disk, and create a device called software RAID 0 or software RAID 0. And we'll put in our password. And that's created and attached our virtual device SD0, which is our encrypted provider. And then when we type exit, it'll go back to the main menu and allow us to enter the installer. So we'll do I to install, choose our keyboard layout, host name, configure networking, put in our root password.
Wait, did we not set up an unencrypted partition?
With OpenBSD, they can mount the encryption just out of the bootloader.
Oh, nice.
Yes.
Okay.
Another advantage of being really small. Set up SSHD and everything. No, we don't want X. Set our time zone. So now we have the option to install. We can install to WD0 or SD0. We'll choose SD0 because that's our encrypted software RAID provider.
Sure.
And then we'll set up our partitioning. Oh, sorry. We'll choose the whole disk and then set up our partitioning, and we'll create. single slash partition. Save that. And then we're going to do the install off the CD.
Which should be very quick,
Yep.
I'm sure.
I'm going to opt out of installing all of the X things because we don't need X. And then zap, 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 and it'll install OpenBSD.
Oh, I see here in the notes. Yeah, just right out of the bootloader it asks for the passphrase.
Yep.
Cool.
I wonder how much it would take. Gelly's probably a little more complicated because you would just need GOM before you could even start doing that.
Yeah.
It seems like that'd be
fitting that in the bootloader may not be feasible.
Yeah. Although they managed to get enough to understand ZFS in like 45 kilobytes. So as long as you I created that first partition for the bootloader on my system. I made 512 kilobytes.
I wonder if it's different on GPT because we're creating that separate little boot partition.
Yeah, on GPT it should be possible because you're doing that separate burst partition.
Plenty of room because that's how we do it with Grub too. Like we create a 5 megabyte little partition.
Okay, so now we're dropped into the shell on our installed OpenBSD system, and we just need to make we can make some last minute changes. I'm going to change some flags in the fstab file. There we go. We'll add that swap partition to the fstab file. And we're good. And now we'll reboot, and it should start our machine, and we'll see the encrypted bootloader.
Cool.
Unless I've managed to munge that up as well.
Oh, hopefully you typed it all right.
Oh, right. The reason it's not working is I haven't unmounted the CD yet, so it's booting off the CD again.
Oops.
I was like, it didn't ask for a passphrase. There we go. Now it's asking for a passphrase.
There you go.
And then it will boot.
I know they use the passphrase. Is there another file that has part of the key in it you need to back up? OpenBSD as well? Maybe worth looking into for the tutorial notes for later.
Possibly. You'll have to ask TJ about that.
Okay.
Also, there's that other OpenBSD tutorial that we linked to in the first half of the show.
Okay. Yeah.
They might have a little more detail or something.
Cool.
Anyway, you can see our system coming up off our encrypted machine.
Oh, very cool. So now that you've showed the two difficult ones,
I'll just do I'll just do a quick version of the FreeBSD one. Oops. Somehow that decided it should go somewhere else on the screen. Okay. Not quite in line with the capture. There, can you see that okay? I think so, yep. Okay, so now I'm going to show you how you do encrypted ZFS using FreeBSD 10. So again, we'll choose to do our install. This is the fancy new key map menu we introduced in 10. It allows you to select your different keyboard type, like it did in 9, it asked, do you have a strange keyboard? And you said yes or no, and if you said yes, it'd give you a list. In this one, it allows you to select one and then try it and make sure it's the right one before you continue the install, which we found is very nice. So put in our host name and select some stuff to make it install faster. Configure our network card. Select FTP mirror. And I'll choose the ZFS option from the new menu. And I can then go into this part here, select what type of ZFS I want. I only have one disk, so I'll do striping. and then I can just select from a list of all the disks I have. Then I can decide what name I want to have my pool, and if I just click there, I can choose to encrypt my disks. And then I just proceed with installation. Am I sure I want to destroy that? Yes. So it'll take care of destroying that. And now it asks me for the password for my encryption. And the second time, now it's going to go and create those encrypted setups on each of those disks. And now it's going to install the system onto the encrypted disk.
Just ran those gpart commands for you.
Yes, all the gpart, all the Kelly commands, everything. It actually uses key files that are then encrypted with your passphrase and stores them in your /boot and everything.
Always put on our boot keys.
/boot and then the name of the disk .key.
Okay.
And it also stores the backup files there as well.
Cool.
I think. I don't know. You have to ask Devin.
Yeah.
It's documented in the man page what it does. So now it's installing. Just take a second, and then we'll have a fully functional system with root on ZFS and everything.
Sweet. So does yours create two Z pools?
Yes.
Is that how this
yeah.
one's working?
So it has one Z pool called boot pool, and then a second one called whatever you set the name of your system when you created it. And the boot only one by default is 2 gigabytes, which is designed to be enough so that you can have, your full install and then your kernel.old when you're doing an upgrade and stuff, and not get your pool to be overly full. It's less of an issue now in 10, but in older versions of ZFS, if the pool is overly full, you could have some performance issues.
It got cranky when it got above like 90%-ish.
Well, in older versions, it got cranky when it got above like 75%-ish.
Oh, man. Ouch.
So that's why we opted for 2 gigabytes.
Gotcha.
So if you're going to do encrypted root on ZFS in VirtualBox, you need to make your disk bigger than 4 gigabytes. And now we can see it's booting, as you'd expect. And this time, because the scripted version never misses a step, you'll see after it loads the kernel here, you'll see it load all the crypto stuff that we need.
Cool. Whoa, that was too easy.
Yes. Wasn't that easy to write at all, to get it to do it perfectly every time. Especially, it also deals with the case where there's stuff left over from, your last attempt or whatever. Although it warned you because it assumes it takes the whole disk and will blow away whatever's there and overwrite it with encrypted gibberish. So you need to be careful using that. The ZFS option is only for machines that are completely dedicated. So yeah, you can see it's loading the ZFS modules, and then it should load the crypto modules. Yep, there's the crypto module. And that's that.
Very cool.
Yep. And as always, the full notes will be on the website and go into detail and explain each of the steps as it does it and explain all that fun stuff. And yeah.
Well, fantastic. Well, thanks, Alan. Great tutorial. Thank you, TJ, of course, for working on that. That was absolutely awesome. So next up, we'll be back in just a second with the weekly news roundup. So first up, OpenZFS held an office hours session, it looks like last week, and it was our buddy George Wilson who sat down and did that.
Yeah.
So that's really cool.
Even more questions about ZFS. The office hour ones tend to be a little more developer-based. It's for people who are working on ZFS and ZFS features and stuff to ask questions of the subject matter experts. But they take user questions and stuff as well, or just general questions about, how does this work, or will we ever have this feature, and things like that. So it's a good hour-plus long video of things people want to know. And they're great, and I think they plan to do a bunch more of those with Matt and George and other people.
So definitely hit the links afterwards. Those are just fun if you want to kind of see the evolving future of OpenZFS, what's happening. I mean, that's just a really cool way to keep up to date with that stuff.
Yeah, and if you missed it, there was one a couple of in I think October with Matt Ahrens, which is also up on this website somewhere.
Cool. All right, next up we have license summaries in package.ng. So there's been a discussion going on, it looks like, between Justin Sherrill and some of the New York City bug guys about license frameworks in package.ng. So I guess looks like similar to package source's acceptable licenses setting, package.ng could possibly let users decide which software licenses you want to allow to be installed. That's actually pretty cool. So maybe we can get a package licenses command to display the licenses of all installed packages as well while you're at it, Bapt. I mean, not like you got anything else to do. I mean, geez.
Yeah, well, part of it is you'd have to change the ports infrastructure to actually track that. But from conversations I've seen in the BSD ports directory, Eaton Adler was working on cleaning some of that up so that it might be useful.
Yeah, they started changing that. I forget how many months back it was now, but yeah, most of the ports now are including licenses because we're pulling licenses out for our PBIs as well.
Right, and because there's something similar that was added a couple of years ago where the actual license, the text of the license gets installed into a directory the first time you install a port that uses that license or something.
Okay, I'll have to look at that, see how that works.
I think it's the same thing. But this basically would allow you, if you're trying to build something, to be able to tell what licenses various things are under so that you can say, I only want to use things that are under these specific licenses, which could be very useful if you're building like an embedded application or something.
Very cool. Okay, so cool. Well, hopefully we'll see some more information about that in the future next year. I'm looking forward to it. So next up, we have something about the FreeBSD challenge. If you remember, we mentioned, was it last week or the week before?
Alan? I think it was last week, judging by how many days have gone by.
Yeah. The Linux Cauldron had did an article on the FreeBSD challenge, so we're checking in with our buddy over there from the Linux Foundation, and he has his blog post, switching from Linux to FreeBSD, and I guess he's doing his month-long trial. So interesting thing, I guess he must have heard some of the comments from the show last week. He says, matter of fact, I did check out PCBSD and wanted the challenge. So call me addicted to pain and suffering, but the pride and accomplishment you feel from diving into FreeBSD is quite rewarding. I'll give you that. I mean, maybe we made it too easy, right?
I suppose it's possible.
Yeah, so if you want to do it the manual way, that is cool too. I mean, you're basically just simulating what we do. Just like when we did the tutorial earlier today on setting up Jelly manually, or you just hit enter a couple times and type a password in, and it just does all the stuff for you. So, anyway, since we last mentioned it, he decided to go from a VM to real hardware. He got all his common software installed. He's experimented with Linux simulation, set up VirtualBox, learned about slices, partitions, and BSD-style disk management, and found some alternatives to his regularly used commands from Linux and lots more. So, very cool. We'll have to keep following that, Alan. See how that goes.
Even looks like he's playing with running a Steam server. Playing, what game was that again? Fallout or Killing Floor. Sorry, Killing Floor.
Killing Floor. Okay.
Yes.
Oh, very cool though. Okay, excellent. So of course the link will be there in the show notes. So take a look at that.
Yeah.
And next up, I guess Ports gets a stable branch.
Yes.
What is that?
So they're going to have a branch called 2014 Q1, and basically it'll be a snapshot of the ports tree that'll be maintained for 3 months from its release. And that will include the only allowed commits will be security fixes, build and runtime fixes, infrastructure changes, which is, BAP changing stuff for package.ng, and other cases with the permission of Ports Manager. So this will allow, if you want to track kind of a specific point in time of apps and not have to worry that, if I script, PKG upgrade to happen automatically all the time, that it's not going to randomly change the version of my app and cause a problem.
Sure.
So this way you can be guaranteed that for that 3-month window, the major version of the app you're running isn't going to change.
Sure. That's cool.
Yeah. I guess like package sources had something like that for quite a while. And for a while it was kind of decided that'd be a lot of extra work for the ports team, considering they're already trying to maintain all this, but
it is.
They decided that it's something we need, and so that they will take on the extra work anyway. Well,
I'll mention we're getting ready to do something similar with a PCBSD, probably starting in 10. it looks like what we're going to do is have 2 port branches available for the 10 release, and then releases going forward. And we're renaming them something a little different. We're going to have production, which is going to be like our quarterly release. So you'll have a quarterly set of packages. And then we're going to have an edge set, which will be updated every couple weeks with the new, latest, greatest bleeding edge stuff. And of course, Edge will be more for your developers and adventurous types, whereas if you just want, a rock solid system and don't want to worry about a VirtualBox breaking on you because of an upstream change, then production will be the way to go.
Yeah.
Cool. Looks like that's
interesting to see the results of that. And I guess even just comparing that to your work with rolling release versus the snapshot of the operating system itself.
Correct. So on like our FreeBSD stable branch, we'll keep that more like an edge branch where it's going to be getting updated every couple of weeks, and that's again for the very adventurous development types. But for somebody who just wants to splat 10.0 release down and then not have to worry about updating major desktop components every week or two, I think this will probably be a lot more stable solution for folks.
Yep. Yeah, and that way you'll always have something you'll be like, well, if you can't complain it breaks if you're not running the production one.
That's right. And if you have a problem, roll back to the production branch. At least you'll have a backup now.
And that's fairly easy to do with package-ng now. So
we're going to just put a graphical thing in our system manager where you can just click and say, okay, production, nope, back to edge, oh nope, back to production.
Cool.
And do an update, and there it goes. So hopefully that'll be very easy and convenient for folks. So next up, we're going to be getting the feedback and questions from you out in the audience. Okay, next up, we have feedback and questions from you guys in the audience. So keep those coming. We enjoy getting them, and we know you guys are out there trying to stump us too, but hopefully we'll have some answers for you this week. So first up, we have John. So what's John asking us out?
So first he says, thanks for answering his question last week, and congrats on having a sponsor. It shows the quality of the show and so on. And he says, just to follow up, it went very well, he says. He can now max out his network without FreeNAS even breaking a sweat using sandwich shares. He says he has all the plugins going, and he's tinkered with the jails to set up his XBMC and actually to keep track of which files he's watched in an SQL database. And he points to, there's a section on the XBMC wiki that actually shows how to do it with FreeNAS. And he says he enjoys having the jails as a safe place to be able to tinker with stuff without risking messing up the whole system or anything. He says the outstanding issue is that his case has 2 chassis fans attached to the motherboard, and they run at 100% speed all the time. And he says Windows would somehow control the fans, and he's wondering if there's a management tool. I've used MBMon to look at temperatures and stuff. I don't know if it controls a fan or not. Usually my solution to that problem is to buy different case fans that have a temperature probe and take just a regular like Molex power connector, the 4-pin, and they will adjust their speed based on the temperature sensed by the probe rather than being controlled by an operating system or something.
Which makes sense. That's probably a good idea.
A manual fan control is also an option. That's what I had when I was in college, because I would crank it up all day and then turn it down at night when I was trying to sleep with the computer in the room. Also, I had lights for the windows in my case that I would turn off when I was trying to sleep.
Oh, yeah. You had one of those tricked out PCs, huh?
When I was in college,
the neon?
Yes. Well, it's cold cathode, but yes. Neon gets really hot, which is bad.
Yeah, you don't want that there.
But, so you don't necessarily need a manual fan controller, but they make regular like 80 millimeter case fans that'll be slightly that'll have a temperature probe hanging off of them, and they'll base their spin speed on that instead. And the advantage to that is they don't go to full roar ever, really, unless they detect that you need that.
Cool.
But other than that, I'd say look in the ports tree. If there is something, it'll be in there. I've never had to deal with that. I mostly use servers now, and so all the control stuff is done that way. And he says, just as a comparison, using the same hardware, he used to have Windows 8 with the RAID 5 on it. Switching to ZFS and FreeNAS, he now, instead of getting 50 to 60 megabytes read and 30 to 40 or 20 to 30 write, he now gets 90 megabytes per second read and write using FreeNAS, and which pretty much saturates his gigabit network.
That is cool. That is really cool.
My RAID Z2 with 6 3 terabyte disks does 650 to 750 megabytes a second. Which is really nice.
Very cool.
Yep.
Okay, it looks like hopefully we answered all his questions there. And next up, we have something from Spencer asking about jail scripts. So he says, first of all, he's new to Unix and FreeBSD, so welcome. Glad to have you out there, Spencer. He's been addicted to jails ever since reading our Everything You Need to Know About Jails tutorial. Very cool. He's been messing around so much in FreeBSD. The idea of creating and destroying jails is great for experimentation without worrying too much about not being able to reboot after you screw something up. Likes the idea of having a unique IP address for each jail, but he's wondering if there's a way to automate the part where you create IP addresses and use that information to create the jail. In other words, it would be really neat if I could just call the script, specify a specific network adapter IP hostname for the jail. The script would then create the network alias, add the info to rc.conf, create the jail, copy resolve.conf, etc., etc. Basically, you want something to automate the creation of jails. So actually, yeah, there's several things out there to do that. So Alan uses EasyJail, right?
So with EasyJail, when you create the thing, the default is you just put the IP address, and it assumes you would have to bind that IP address. But if you put the name of the interface, like EM0, pipe, you'll have to escape the pipe because normally that would do something else in your shell. And then the IP address, when EasyJail starts that jail, it'll bind that IP as an alias. And when you stop the jail, it'll unbind it. So it allows you to, it's not even going to mess with your rc.conf, it's just going to do it as part of EasyJail. So that when the jail's stopped, the IP gets disconnected so that it doesn't point at your host. Because with the way jails work, if you don't reconfigure SSHD to not listen on the jail IP, when the jail's running and you SSH, you'll connect to the jail. But when the jail's not running, you SSH, you'll get the big scary warning because you're connecting to a different SSH key. Which is the expected behavior, but having it completely unbind that IP may be what you prefer.
The better solution where it actually goes away like the machine powered down.
Yeah. So I've actually switched to using this mostly because if you forget to add this IP to rc.conf, like you add it as an alias, but forget to put it in rc.conf, 6 months from now, you upgrade to a newer version of FreeBSD, so you have to reboot. And then the jail comes up, but it doesn't quite work right because it can't get the internet because the IP doesn't exist.
That's right.
EasyJail does it. I guess Warden, how does it deal with IP addresses?
So the site I'm on here is I use Warden, which is a utility I actually wrote for PCBSD that we've put in the FreeBSD ports tree as well. And it does exactly the same thing. So with Warden, you'd specify your adapter in the configuration file. And then you would just say, create a new jail, give it an IP address. There's even support for like vimage. So if you want to do it on different subnets, etc., you could. But once you give it the IP address, it'll create the jail, create the host name, and then it does the same thing where it'll create the IP address alias at startup. And then when you shut the jail down, it deletes it and it goes away as it should. And there's no messy mucking around with etcrc.conf, none of that. I mean, it's going to set up the resolve.conf, set up the host name in the jail and everything. It just automates it all for you. And it does some neat stuff in the background with ZFS and cloning and whatnot to make it very quick. So your first jail may take a couple minutes to extract, and then after that, creating a new one's just a second or two. Yep. So it's definitely very cool.
Yeah, Warden is nice. It has a couple more features for doing stuff with ZFS. But I've been using EasyJail so long, and I'm just kind of ingrained into it.
Yeah. So Warden, some of the other stuff is we're really big on ZFS, right? So Warden has a lot of integrated things where you can set scheduled like ZFS snapshots for your jail. So if you know, okay, I want to have this snap every 10 minutes or once a day, every hour, whatever, you can do all that in Warden and then roll back. And rolling back is really cool. If the jail started, it'll stop everything, roll it back, and then start it right back up for you. So there's some neat little features that it takes advantage of the ZFS system underneath. So that may be something to consider if you're running on ZFS. Yep. And that's Warden, I should mention too, that's what FreeNAS uses for its jail. Yep. So if you're planning on doing FreeNAS stuff, you can also use Warden there. And the cool thing is it has import and export. So you can create a jail on FreeNAS or PCBSD, export it, it just dumps it all to a file, and then bring it to your new host, import it, it brings back all the IP information, hosts, etc., and starts it up on the new system. Like it never went away. Yep. It's pretty cool.
It's awesome. Well, that's one of the biggest things I loved about jails was I create this almost virtual machine, but with full speed and full access to all the hardware. I didn't have to say this can only have so much of this RAM and nothing else can use that RAM. I just say, their access to all the RAM or whatever.
Sure.
But, here's a video server. It's running on here, and it's like, oh, well, I'm going to take that machine down to do a bunch of maintenance on it, or I'm just retiring the machine or whatever. I can EasyJail stop, archive, move to another machine, create from that archive, boom, it's back up. It picks up the IP addresses. Well, I have to give it the IP address again, but and it starts back up, and the jail doesn't know that it's now running on a different machine.
Yeah, I mean, it's got access to all its same files. It's
exactly.
Essentially backing up a directory.
Yep.
So
it works great.
very cool.
Okay.
Well, hopefully we answer your questions there. So next up, we have something from Campbell.
Yep.
So what you got here, Alan?
He asks about the BSD development structure. He says, been listening through all your shows and enjoying the insight into the world of BSD. He's mostly a Linux user and developer. Well, he does have some BSD setup on a second system to help him kind of learn this stuff. And he apparently helps maintain Blender 3D for the BSD ports tree.
Oh, okay, cool.
And one thing he finds interesting about BSD is how they maintain userland and kernel in one repository instead of being completely separate projects. You've mentioned this is a benefit since you can polish and make an integrated system and so on. He imagined that there's two drawbacks to doing this. He says if there's a disagreement, you end up with a fork of the operating system. Well, that's possible. The last real serious fork of BSD was 10 years ago. But anyway,
that would be Dragonfly for those who don't know.
And in his example was PCBSD, but that's not actually a fork. It's more of a spin or a flavor or something.
Yeah, I guess a flavor would be the best way, or a focused, targeted version of FreeBSD.
It's a package set on top of FreeBSD.
Yes, that's pretty much how it works.
Yeah, and Midnight BSD is similar, I think. It's
there's a few others, Ghost BSD, Midnight BSD, etc.
He talks a bit about duplicated effort. Because the kernel's not the same, the effort's not so much duplicated. There's quite a bit different. But there's a lot of sharing going back and forth. Like BAPT is working on porting the newer PF code into FreeBSD and so on. But I think they actually make a point about that one in here. And he says that the code bases diverge sometimes, and that's possible, but that's what happens.
You got to have some of that so people have a place to experiment with new ideas and features that maybe you couldn't push into one BSD at the time. I mean, that's what the forks pretty much happened over originally. And
then he asks, sometimes there's a bug found in one BSD and then the other one finds it months later, and if they paid attention, they would know. It depends. If code is shared, usually there's some kind of maintenance setup so that you would find out when something like that happens. Like the M tree implementation of FreeBSD is now the one from NetBSD. So if they patch it, then we'll pull in a newer version next time we're doing a major update of FreeBSD and things like that. So it doesn't happen that often, really. Like, I don't think there's that much wasted effort or bug fixes that aren't getting into the various BSDs.
Sure.
The odd time when there's a problem, it's usually because of diversion over something. Like, FreeBSD has the older version of PF because they made a lot of local changes to it to improve the SMP, and then OpenBSD did that. But because SMP and OpenBSD and FreeBSD are entirely different, the changes aren't really compatible. And I guess the other one was OpenBSD changed the syntax of the rules, and FreeBSD didn't want to do that in the middle of a release cycle. And now it's too late.
Well, it may lag behind. Then in a year or two, somebody will be like, "Hey, let's port over the new one."
Well,
fix some things. So
hopefully, BAPT can somehow find time to do that. I don't know how.
Yeah, we keep loading up BAPT with more.
Well, he volunteered. Is the strange thing. Like, and unlike when he volunteered for the ports manager team, I don't think somebody had their fist to his face.
Yeah, like he really wants to. Okay, so that's cool. Maybe he'll do it. Okay.
So I don't know that there was
you answered all the
necessarily
questions.
a question in there, but
it's more of a wanted your opinion on it. All right. Well, the next question we have is Shaul. He's asking about backups. So he has a question for us. well, for either us or the show. So you're getting the answer on the show. Pretty cool. So what's the best way to back up comp files off the system? So for example, if he has to erase the hard drive or drive dies, how can he pull all the different comp files back in place without having to write them over again? Let's see, I don't have a server to send everything to, an old computer. And the old computer I could try and set up the server is a Pentium 3, but I can't tolerate the PSU and heatsink noise to leave it on all the time. So essentially you want to do a backup, but it sounds like just the comp files?
Possibly.
Yeah?
Yeah. Well, the USB stick works or whatever.
Yeah, USB stick. I'm trying to think of a way to automate it. What I would do, if I had to do that, I would just use a USB stick. I would back up all the comp files and use your local Etsy.
Yes.
And then
maybe
I would also
main
save
etc
a
as well.
list of packages.
Yeah.
Oh yeah, in like etc RC, and there'd only be a few in there that I would have to back up because I may know that I only tweak sysctl.conf for rc.conf for .local or something. But if you back those up, and then I would in addition do a package info dump.
Yep.
So I know what I had on the system, save that to a text file on the USB stick. So at least if the system goes down, worst case, all I got to do is plug the USB stick in, look at my package info list, make sure I add all those packages again.
Yep. And then restore those config files.
The config files, and away you go.
Yeah. And if you did that with rsync, you can set it up to do a different directory for each day, so you could keep snapshots basically of each day. And it can do hard links so that it only backups the files if they change and stuff. But yeah, I wouldn't trust a USB stick with your only backup of something either. No,
this would be I'm thinking more of like if you know you're going to erase the drive or replace the system or something, you just want to do a quick way to migrate it all over. But otherwise, I mean, backups,
Well, backups,
there's better solutions.
The easy answer is Tarsnap, I suppose, which is Colin Percival's backup service that's designed for BSD. And it lets you back up files, and you pay like 300 picocents, which is like trillionths of a cent or something like that, for each gigabyte month of storage.
Oh, okay.
So it's if you're just storing .conf files, it'd be really, really cheap, and it does like incremental backup, so you're not going to send the whole config file every time, only the changes. And he's got a cool algorithm for finding the largest common change that it can.
Okay. Very cool. Hopefully that gives you some ideas, though, on some different ways possibly to do it without having to spin up another system locally.
But yeah, for backups, your general rules are if there are not at least 3 copies, it doesn't really exist. And you want to have more than just copies. You want to have like dated things, because if you rewrite the config file to make some change and then realize that's bad and you want the old one back, well, if you've already backed it up, if you backed up the new one, then you don't have the old one anymore.
So one of the things I was doing with one of my systems here was using ZFS, of course. I would attach a drive, as in a mirror, and an external drive, and then I would detach it and go put it in a fireproof safe or take it off site. And so at least I could do that periodically as like kind of a full system backup. But I don't know. There's different ways to do the same thing, but that would be like everything. So you'd have to have another drive of the same size or bigger as your existing disk. But hopefully that at least gets you thinking on some different ways to do that. And if you come up with some unique, cool way or write a nifty script that does it, let us know. We'll plug it for you.
I guess the easiest solution for backing up stuff is Tarsnap.
Yeah, definitely.
It's all encrypted on your machine before it goes out to there, so no one else can read your config files and anything else like that. So last question is from Clint about L2ARC, ZIL, and ZVols. So he says he's loved our podcast about ZFS, and he wanted to share a story about some non-standard ways he uses ZFS. So he says he has a root on ZFS with Jelly encryption. It's all set up. Apparently, he says sysinstall, but I'm sure he meant BSD install. He says he also has a volume that he's uncreatively called Tank. So I guess he means a
tank
pool, not a volume, which holds all his large data for his file system. And he says since his root Z pool is on an SSD, he wanted to use some of the SSD for L2ARC and for a ZIL. Although you only need a ZIL if you're doing synchronous writes. So, on a laptop or something, you're probably not doing all that many synchronous writes. that a ZIL is going to make that big of a difference. But and if the whole pool is on an SSD, then having a ZIL on the same SSD is just wasting writes. But
kind of defeats the purpose. But yeah.
So he says what he did was made a ZFS volume on his pool, and then used that volume as his cache and log devices.
What?
That I don't how. That's really bad. Yes, that's very, very bad.
Sounds very bad.
It's definitely not helping performance because you don't want to be doing copy on write on your L2 arc.
Well, I wonder if you could lock. That would be the same as like doing swap on top of ZFS. I wonder if you could potentially lock the system where it would
possibly a little bit, but it's definitely not going to help because if your read cache is just on the same SSD that the files were, you're reading the file and writing it out to somewhere else on the SSD to read it from somewhere else on the SSD, which isn't going to be any faster than reading it off the first place on the SSD. It's just going to burn up your SSD a lot faster. You know, if you have an SSD and your pool's on the spinning drive, it kind of makes sense. But I'm really surprised that ZFS even let you do that.
Attach that.
But I suppose, you know, the usual Unix mantra is don't prevent you from doing something stupid because that would also prevent you from doing something clever. This is not clever.
This is probably a really bad idea.
Anyway, he says another interesting story he had when he used, again, he says sysinstall, but I'm sure he means BSD install. He said it insisted on a swap partition rather than doing swap on ZFS volumes. Yes, we do that for a reason. Although you can set the size to 0 and it will not have swap. Not sure why you'd want to do that, but anyway. He said he preferred that the swap gets encrypted. You can do that. We just didn't build it into the installer. You can set up Geli to encrypt your swap with a different key. So when you reboot, it picks a random key, encrypts to that, and when you reboot again, it never wrote down that key, so it doesn't know it. So it just picks another new key.
Lost.
So it's impossible to decrypt your swap because the key is never stored anywhere. No one ever had the key to be able to decrypt it.
So I think that's just editing FS tab and putting .eli at the end of the swap. Right?
I think you still have to Geli init it first.
You still have to?
I'm not sure.
I have to check because I think at one point there was just like you could do swap, encrypt, innate. There was like an rc.d thing even.
Yeah, I think it was rc.conf. You just had to add swap is encrypted or something. Something, and it'll do it all for you.
It's like a one-liner. It's not that big a deal.
So anyway, he says, so he installed the default with a 4 gig swap partition, and then did swap off to stop using it. Deleted that swap partition, and then found that he couldn't extend the ZFS container on top of it while the zpool was using it. Yes, you can't do it while it's in use. So he says he created a ZVol on tank and added that as a mirror to the root. And they took the SSD partition offline so you could extend the partition.
Add it back and then remove the mirrored device.
Yeah. That's kind of crazy.
It worked.
Yeah.
You know,
you could have booted off the installer CD, dropped to the shell, and done it and then rebooted, but that probably works better. But anyway, I suppose.
But his point is being able to do that kind of manipulation on the root file system while it's booted was nothing short of amazing, which would be a case in his favor here where it's like, I don't want to shut the service down. Boom, do a couple commands, and I was able to extend it. Done. So that is kind of cool.
Yep.
Well, cool. It says, thanks for the great podcast.
Looks like in rc.conf it's Geli_swap and Geli_swap_flags where you can set the... use AES XTS with a 256-bit key in 4 kilobyte chunks or whatever.
Yeah, piece of cake. There's no reason not to do that.
Exactly.
I should just turn that on by default on PCBSD. I don't know why we don't. But
if they don't have AES-NI, it might actually be a performance hit.
Yeah, but honestly, we ran without even doing swap for so long on a lot of our systems here just because it wasn't necessary. We had very few people use it. But now that we're doing swap again, maybe we'll add that on.
Cool. And so
Awesome.
that's the last question, I suppose.
Okay. Well, excellent. Well, thank you guys for sending in the questions. So we appreciate it. Keep on sending in anything pops into your head, and we'll try and answer it to the best of our ability. So as usual, all the tutorials are going to be posted in their entirety at bsdnow.tv. So after you watch the episode or while you're watching, go ahead and take a look there. And it's easier to be able to click on the links that we're talking about and follow along. As usual, send your questions, comments, show ideas, topics, or any stories maybe you want mentioned on the show to feedback@bsdnow.tv. That's the only place we really monitor, so please send stuff there. Don't try and ping us on other social media sites because we may not see it. Yep. If you want to watch us live and catch all the cool little banter that happens in between segments, and maybe even we'll answer some of your questions in the non-recorded segments via IRC or just over the show here, we'll be happy to do that. But you can watch us live at 2 p.m. Eastern, 1900 UTC.
Yep. And I guess other news, the FreeBSD Foundation and the OpenBSD Foundation also accept Bitcoins for donations.
Oh. Okay. Yeah, I see that here.
And apparently the NetBSD Foundation is working on that as well.
I mean, at the price of Bitcoin, that just seems like a no-brainer.
And they're using one of the APIs that converts the Bitcoins to the equivalent cash right then. So they'll get the value of what they're worth now.
So they don't have to worry about the risk of maybe it crashing. Yeah, you never know.
Yeah, well,
Bitcoin's still one of those things.
It's been going down pretty hard this week because the Chinese government banned their banks transacting in it or something. Anyway, and also thanks to our sponsor, IX Systems. And remember, if you go to ixsystems.com/BSD Now, you can get a free copy of their white paper that explains some of the things you should look at when you're buying a server. And you can also contact them and get a consultation and find out what's probably the best build for what it is you're trying to do. Because, depending on what your needs are, most people don't realize that depending on what kind of files you're storing and what kind of use you're applying, you don't necessarily need a ZIL on your ZFS pool, right? If you're just storing large files and it's all asynchronous, then a ZIL is never going to be used, and spending, thousands of dollars on really fast SSDs for it is a waste of money.
Yeah, for no performance. I mean, shoot.
Whereas if it's a database, then you probably want a ZIL. And also they recommend different types of SSDs for a ZIL versus an L2 ARC because you're talking about different levels of write endurance and read speed and IOPS and all these different considerations.
But the point is, IX has all those people who will answer those questions for you.
Yes.
So you don't have to do the research and figure out how.
They've used the different drives, and they have the telemetry from lots of FreeNAS and TrueNAS boxes where they know these SSDs work better than these SSDs. And so we'll recommend people use, for our system, we have 2 of the Intel S3700 Data Center Edition ones. They're a bit more expensive, but they're really nice and extremely fast. And the big difference is the write endurance compared to the cheaper S3500s. An S3500 can write like 140 terabytes for a 240 gig SSD. For my 200 gig ones, they can do like 1.3 petabytes. Nice. So the SSD is going to last a lot longer. It's like you can.
Yeah, it's definitely worth the extra.
Yeah,
a little more bang for your buck there, man.
The difference is like certain amount versus writing the entire drive 10 times a day for 5 years. It's like that should be enough to last me for the 5 years.
Well, definitely go check out the link again. That's ixsystems.com/BSD Now to get all those details. Maybe get in touch with somebody who'll be glad to help you figure all that stuff out for your project. So, of course, be sure to support the projects that you use and love. So, again, we mentioned the FreeBSD Foundation. So, if you haven't donated yet, try and get that in before the end of the year. And as usual, we'll be back same time next week with a slightly shorter show since it's obviously Christmas. We'll have something recorded for you guys to watch. And then we'll catch you again live in the new year.
I just saw IX Systems posted the full stats or specs for that big machine that they built for the FreeBSD Foundation. That's a quad socket Intel. They're E5 4850s. So that's 10 cores each and 4 sockets. So it works out to 80 cores. It's got dual 10 gigabit Ethernet, 32 times 32 gig DDR3 ECC memory, 6 Samsung 512 gig 840 Pro SSDs in a RAID 10 setup, and they're working on when it goes through their QA process where they make sure everything's going to be perfect so that when the FreeBSD Foundation gets it, it's going to work. They're going to post the D message up for everybody to see.
Fantastic.
Yeah.
Well, we'll try and get a link, hopefully, in the show notes for you guys to take a look at that bad boy. That's awesome.
Yes. Somebody in the chat room says, that's not enough RAM. I think with an E8450, you can do the theoretical maximum is actually 768 gigabytes per chip times 4 of them. So it could actually handle 3 terabytes. But the most you could fit in the slots that are on the motherboard, I guess, would be 2 terabytes if you could find 64 gig DIMMs, which are very hard to find if they even exist and would be ridiculously expensive. I think a terabyte is enough RAM for now.
Yeah, for now, I think you'll live.
Yeah.
Cool. Well, thank you guys so much for being with us on the show today. We'll look forward to seeing you next time.